Hi, in this video, we're going to solve the Pure Math 1 paper from a June 2022 series. Let's have a look at the first question, where we have to complete the square. So we have a very standard procedure for that. We're going to write it in the form x plus some number squared, and that number should be the half of what used to be next to x. So this is 4. Then next, I will have to subtract the square of that number, which is 16. Then don't forget to add 11, which used to be there previously. So all in all, we've got x minus 4 squared. Then minus 16 plus 11 is going to be minus 5. So that's the form they were asking for. And I will state this as the final answer. X minus 4 squared minus 5. Let's move on to the next question. So hence find the exact solutions of the equation. Okay, I'll replace the left side of this equation with my complete square form, which is x minus 4 squared minus 5 equals to 1. Now let's move minus 5 to the other side, and we'll get x minus 4 squared equals to 6. Take the square root. X minus 4 equals, don't forget that we have two values, plus or minus. And then finally move minus 4 to the other side, and we'll get 4 plus minus the square root of 6. And that's the exact answer for this equation. Let's state it. Answer 4 plus or minus square root of 6. Time for the next question. So this question is about an arithmetic progression. The 13th term of the progression is 12, so I will say A13 equals to 12. Now the sum of the first 30 terms as 30 equals to minus 15. We're looking for the sum of the first 50 terms. So as 50 equals to the question mark. Okay, let's start with the question. We're looking for the sum of the first 50 terms. And the formula for that is the first term plus the last term, which is A50, divided by 2, times the number of terms, which is 50. And then at this step, we can simplify the fraction, 1/25. So we got 25 times A1 plus A50, and close the bracket. Okay, we don't know A1 and we don't know A50. However, we know that A13 equals to 12. So let's write down the formula for the nth term of the progression. An equals to A1 plus d times n minus 1. A13 equals to the first term, A1, plus, we don't know the difference, but n equals to 13 minus 1 is 12, times d. And that should be equal to 12. So that's our first equation for A1 and d. We also know that the sum of 30 terms is minus 15. Let's use it as well, as 30 equals to the first term plus A30 divided by 2 times the number of terms, which is 30. We can also simplify that, 1/15, and we get 15 times A1 plus A30. Okay, at this step, right, that equals to minus 15. And it looks like we have simultaneous equations. Okay, so we got A1 plus 12d equals to 12. Let's divide both sides of that equation by 15, and we get A1 plus A30 equals to minus 1. Now we've got simultaneous equations, and we have three variables, A1, d, and A30. Let's replace A30 with A1 and d. Again, using the nth term formula. A30 equals to A1 plus d times n minus 1, so we got 29d. And let's substitute it into the second equation. So now we got A1 plus 12d equals to 12. And for the second equation, we got a1 plus 29d equals 2 minus 1. Simplify that, and we get a1 plus 12d equals to 12. And the second equation is 2a1 plus 29d equals to minus 1. Two equations, two variables, we can solve it. But first, let's multiply the first equation by 2. And we get 2a1 plus 24d equals to 24. And the second equation is going to be unchanged. 2a1 plus 29d equals to minus 1. Now, to get rid of a1, let's subtract equations. 2a1 minus 2a1 is 0. That's exactly what I wanted. Now 24d minus 29d is going to be minus 5d equals, and then 24 minus 1 is going to be 25. Therefore, d equals 2 minus 5. Let's find a1. I'm going to substitute d equals 2 minus 5 into a1 plus 12d equals to 12. So a1 equals to 12 minus 12 times minus 5. And I will get 12 minus 12 times 5 is going to be 16. So plus 16. Therefore, 72. Okay, now we got a1, we got d. So that means we can find a. Which a are we looking for? We're looking for a50. A50 equals to a1, which is 72, plus d, which is minus 5, times n minus 1, 49. And that equals to minus 173. Now, we're ready to substitute this into the formula for S50, the sum of 50 terms, which is S50 equals to 72 minus 173 times 25. And this gives us minus 2,525. And I will state this as the final answer. Minus 2525. Let's move on to the next question. Okay, question 3 is about the binomial expansion. And first of all, let's write down the formula. A plus b to the power of n equals to the sum. K goes from 0 to n. A to the power of n minus k, and then b to the power of k. And let's use this formula for our case. That's going to be the sum when k goes from 0 to 5. Got 5c k. A is the first term, 2x squared to the power of 5 minus k. B is the second term, which is k squared over x to the power of k. Now, this is going to be a relatively long sum, but we don't need all the terms. So what we're looking for is the coefficient of x to the power of 4 is a. So we're really interested at the coefficient of x to the power of 4. Now the question is, what term will give us the coefficient of x to the power of 4? Let's find it out. And in order to do so, I will only look at the power of x in this formula. So the first term, 2x squared to the power of 5 minus k, would give me x to the power of 2 times 5 minus k. And the second term, k squared over x to the power of k, would give me x to the power of minus k. So this is the power of x in the expansion. And because I kind of want to link the power of x to what I already know, I know that I should be looking for k, which gives me the power of x equals to 4. Let's expand the brackets and find the value of k, which gives us x to the power 4. That's a very simple equation. Minus 3k equals to minus 6, so k equals to 2. So that means when k equals to 2, the formula will give us the coefficient of x to the power 4. Let's substitute it back. 5c4, then 2x squared to the power of 3, k squared over x, and now we know that k equals to 2. Okay, now let's simplify that, and we'll get 10 times 8 to the power of 8x to the power of 6, k to the power of 4 over x squared. Simplify even further, and we'll get 80 x to the power of 4, and then k to the power of 4. Now the coefficient of x to the power of 4 should be a. What's the coefficient of x to the power of 4? It's 80 k to the power of 4. So 80 k to the power of 4 equals to a. Now we found a. We also know that the coefficient of x squared in a different expansion is b. So again, let's use the similar technique. 2kx minus 1 to the power of 4 equals to the sum when k goes from 0 to 4, 4ck, 2kx to the power of 4 minus k times 1 to the power of k. And again, this time I'm looking for the power of x. This time is a bit easier because we only have one x in the formula with the sigma notation, and that power is 4 minus k. And that must be equal to 2. So minus k equals to minus 2, therefore k equals to 2. Substitute it back, and we'll get 4c2, 2kx squared, and then 1 to the power of whatever it is always 1, so we don't really care about that. Okay, so that gives us 6 times 4, k squared, x squared, which is 24, k squared, x squared. And the coefficient of x squared is 24k squared. That means 24k squared equals to b, and we found a and b. So we're ready to give the final answer. A equals to 80 k to the power 4, and then b equals to 24k squared. Let's move on to the next question. That looks like simultaneous equations. A plus b is 216. And we know what a and b are in terms of k from the previous question. We know that a equals to 80 k to the power 4, and we know that b equals to 24 k squared. So all in all, that gives us 80 k to the power 4 plus 24k squared equals to 216. And we have to solve this equation for k. Let's use the variable change. And say that k squared equals to t. So we have a new equation, but now it's simpler. It's going to be quadratic. Move 216 to the left side. Okay, and then to make things a little bit easier, let's divide everything by 8. So we've got 10t squared plus 3t minus 27 equals to 0, and I'm going to use the quadratic formula. So t is going to be minus 3 plus or minus square root of 9 minus 4ac, that's going to be 1080 divided by 2a, which is 20. So got minus 3 plus or minus 33 divided by 20. If I take the plus sign, I get 3 over 2. If I get the minus sign, I will get minus 9 over 5. But we're not done yet, because we're looking for k, and t equals to k squared. That means k squared equals to 3 over 2, or we have a separate case, k squared equals to minus 9 over 5. Now, for this equation, there is no solution, because we cannot take the square root of a negative number. But we can take the square root of 3 over 2. However, don't forget that we have two values, plus or minus. Here we go. That's the answer for that question. K equals to plus or minus square root of 3 over 2. Okay, next one is about proving the identity. And I'm going to rewrite it as the first fraction minus. I'm going to change the denominator just a little bit. I will go with the sine theta first. Now, I want to combine those two fractions together, and I need the common denominator. So the first fraction is going to be multiplied by sine theta plus 1, and the second fraction is going to be multiplied by sine theta minus 1. So I will get sine cubed theta times sine theta plus 1 minus sine squared theta times sine theta minus 1 over sine theta minus 1 times sine theta plus 1. And that's the reason why I decided to write 1 plus sine theta in a different order, because I want to use the formula a minus b times a plus b equals to a squared minus b squared, which is hopefully going to make my calculations a little bit easier. So expand the brackets on top, multiply out, we'll get sine to the power 4 theta plus sine cubed minus sine to the power 4. Oh, that's 2. So it's going to be sine cubed minus and minus is going to be plus, so plus sine squared theta over sine squared theta minus 1. Simplify that. Sine cubed minus sine cubed is 0. So we're left with sine to the power 4 plus sine squared. I can just factorize it straight away. Bring sine squared outside, and I've got sine squared theta plus 1 divided by... Okay, at this point, I want to bring minus outside, and I get 1 minus sine squared theta. Why did I bring minus outside? Because I know that 1 minus sine squared is cosine squared. So I can just replace it straight away. Minus cosine squared theta. Now, sine squared over cosine squared is tangent squared. We got this minus, which is not going to go anywhere. Then in the brackets we get sine squared plus 1, which is the same as 1 plus sine squared. Which is exactly what we had to prove. Okay, so proven. Let's move on to the next one. Okay, next question is the equation, and we can use the identity we've just proven to replace the left side. So let's do that. Got minus tangent squared theta times sine squared plus 1 equals to the right side, which I'm not going to change. Okay, now I'm going to move everything to the left. And I will multiply both sides by minus 1 so I can get rid of all those minus signs. And now, very important, we have tangent squared theta multiplied by the two brackets, and you might be tempted to divide both sides by tangent squared to get rid of it. However, it's not a good idea. Why? Because you might lose some solutions. So, very important, whenever you have the variable in the equation or something containing this variable, like in this case, tangent squared contains the variable theta, do not divide it. Instead, you should factorize, because if you do divide it, then you will most likely lose some of the solutions. Okay, let's simplify this a little bit further. Tangent squared theta. Now, in the brackets, sine squared and minus sine squared will just cancel out. 1 plus 1 equals to 2. So we get 2 tangent squared theta equals to 0. Now, we can divide both sides by 2. And notice how 2 doesn't contain any variables, so feel free to do so. And we get tangent squared equals to theta. That means tangent theta equals to 0. Okay, take the inverse tangent of 0 and get theta equals to 0. And don't forget, when you have when you take the inverse tangent, you can always add up or subtract pi to your answer. So the second value of theta is going to be pi, and the third one, if you add pi one more time, is going to be 2 pi. Okay, now let's have a look at what the range is. From 0 to 2 pi, not including 0 and 2 pi. So the only solution we've got is theta equals to pi. And I can state this as my answer for this question. So answer, theta equals to pi. Let's move on to the next question. Okay, find the exact area of BCD. And we can see this area is going to be equal to the area of the sector minus the area of a triangle. And I'm going to write it down. So sector minus the triangle. And I will try to find both areas separately. We know that the area of the sector is going to be r squared over 2 times the angle theta. Now for the triangle, I want to use the formula half AB sine the angle in between. Now, AD is adjacent to the angle theta, so that means I will multiply by cosine theta. And for the area of a triangle, I will get 1 over 2 cosine theta times r times sine theta. So the area equals to r squared over 2 theta minus 1 over 2 r squared sine theta cosine theta. And we're given the value of theta, which is pi over 6, so we can just substitute this into our formula for the area, and we will get r squared times pi over 6 divided by 2, that's going to be pi over 12, minus r squared over 2, sine pi over 6 is 1 over 2, and cosine pi over 6 is square root of 3 over 2. And now let's simplify this. So that pi r squared over 12 minus r squared root 3 over 8. And I can state this as the answer. Pi r squared over 12 minus r squared root 3 over 8. You can factor out r squared if you feel like doing this. I don't. Okay, for the next question, we'll have to find the perimeter of BCD, and I've copied the diagram to make it easier to explain this question. Now, we're given that BD is square root of 3 over 2r, and that gives us an opportunity to find angle theta. Why? Because in a triangle, BD is opposite of the angle theta. So it means BD equals to r, opposite, so we have to use the sine. So it's r times sine theta, and we can equate these two and get r sine theta equals to square root of 3 over 2 times r. Now divide both sides by r, so get sine theta equals square root of 3 over 2. Take the inverse sine, root 3 over 2, and that gives us pi over 3. So now we know the angle theta. Okay, we're looking for the perimeter of BCD, and the perimeter would be the length of the arc BC. I'm going to use this symbol for the arc, plus DC, plus BD. Now, we already know that BD equals to square root of 3 over 2r, so this one is sorted. For the length BC, I'm going to use the formula r times theta. And now all we have to do is to find the length of DC. Now we know that AB is the radius of the sector, and so is AC. So AC is the radius, and I will have to subtract AD. Now AD is adjacent to the angle theta, so I have to multiply r by cosine theta. Okay, so all in all, I've got r theta plus r minus r cosine theta, and we already know that theta equals to pi over 3, so all we have to do is to substitute pi over 3 instead of theta. That gives us pi r over 3 plus r minus r times 1 over 2, which is cosine pi over 3. And don't forget, we also have to add BD, which is going to be r times square root of 3 over 2. Now, simplify all of this, and we'll get pi r over 3 plus r over 2 plus r square root of 3 over 2. And this is going to be our final answer for this question. Pi r over 3 plus r over 2 plus r square root of 3 over 2. Again, you can factorize r out and use the brackets, but I'm not going to. Instead, I'll just move on to the next question. Okay, next question is about finding the inverse function, and we have a two-step technique for that. We'll have to swap x and y, and then make y the subject of the formula. So swap x and y first. X equals to y squared minus 4 over y squared plus 4. And now I will have to make y the subject of the formula. I will first multiply everything by the denominator to get rid of fractions. X times y squared plus 4 equals to y squared minus 4. Next, I will expand the brackets. And I will try to collect y squared on the left and everything without y squared on the right. So it's minus 4x minus 4. Now, to make it look a bit nicer, I will multiply both sides by minus 1, and I will get y squared minus xy squared equals to 4x plus 4. Now, to make y the subject, I will have to factorize first. So I get y squared times bracket y minus x equals to 4x plus 4. Divide by the bracket, I get 4x plus 4 over y minus x. And then I will have to take the square root. And at this point, I will have to decide whether I want to take plus or minus. Okay, I will have to look at the original question, and I see that the function is defined for x bigger than 2. So let's say x is going to be 3, and I want to know what's going to happen. And I find f of 3, that's going to be 9 minus 4 over 9 plus 4. So I get 5 over 13. Okay, so that means if I'm looking for the inverse function, the inverse of 5 over 13 must be equal to 3. And not negative 3. Okay, so from this fact, I know that I have to choose plus next to the square root. So I will have to use plus. Okay, my answer, the inverse of f equals to square root of 4x plus 4 over 1 minus x. And let's move on to the next question. Okay, show that some expression can be expressed as a single fraction. Okay, I need a common denominator, so I will multiply 1 by x squared plus 4, like top and bottom, to get x squared plus 4 over x squared plus 4. That used to be 1 minus 8 over x squared plus 4. That gives me x squared plus 4 minus 8 over x squared plus 4, which is x squared minus 4 over x squared plus 4, which is exactly what I had to show. Okay, and hence I will have to state the range of f. That means I will have to look at this expression, because it's literally the same as my function f. F equals to 1 minus 8 over x squared plus 4. Now, the best technique to state the range is to sketch the function. I'm going to start with this bit. 8 over x squared plus 4. Let's draw x and y axes. And let's try to analyze what's going on. So first, let's have a look at the point where x equals to 0. So substitute x in the formula. I'm not really considering the minus at this point. So it's going to be 8 divided by 4, which is 2. Now, what's happening as x is getting bigger and bigger and bigger? Now, x squared plus 4 is also getting bigger, but the fraction 8 over x squared plus 4 is getting smaller. However, x squared plus 4 can never be negative. So that means 8 over x squared plus 4 is going to approach 0, but it's never going to reach it. And the same is going on the left side, because x squared plus 4, again, will take the same value for the positive x and for the negative x. So that is 8 over x squared plus 4. Now, what's going to happen if I put the minus in front? That will be reflection on x-axis. So I will simply reflect my graph on x-axis. So instead of 2, I got minus 2. And I'm approaching 0 from the different side like this. So this is minus 8 over x squared plus 4. And the next step, I will have to add 1. So what it does is the function is going to move 1 unit up. That means instead of minus 2, I will have minus 1. And now instead of approaching 0, I will approach positive 1. So the graph looks like this. Now, here's the tricky part. It's very tempting to say that the range of the function is from minus 1 to 1, but let's have a look at the domain of the function. They tell us that x is bigger than 2. So let's figure out where x equals to 2 is. Remember, f equals to 1 minus 8 over x squared plus 4. That means f of 2 equals to 1 minus 8 over 2 squared is 4 plus 4, 8. So all in all, we get 0. So that means when x equals to 2, y is 0. So that's the point. So we actually don't have the full graph of this function. We only have one piece of it. So we only have this yellow piece of the function. And here's the range of the function. It's from 0 to 1. So the answer, y is from 0 to 1. Let's have a look at the next one. Explain why the composite function f of f cannot be formed. Whenever they ask you this question, probably the answer is that the range of one function is not going to match with the domain of the other. Let's have a look at what's going on in this case. So the function f has the range from 0 to 1. Meanwhile, the domain of the function is x is bigger than 2. So that's a completely different story. And we can say that the range of f is actually not within the domain of f. And I'll write it down as my explanation, because the range of f is not, you can say, fully within the domain. And also it's very important not to just write this sentence down, but it's also very important to actually state the range and the domain of the function that you are given, just to show that you know what you're talking about and not just copying the standard answer for this type of question. Okay, let's have a look at the next one. Okay, question 7. Looks like integration to me, but first we'll have to find the coordinates of A and B, which is the point of intersection. So whenever we have the question about the point of intersection, and we have two curves, we can see that at the point of intersection, the y value of both functions are equal. So we say that y1 equals to y2, and that gives us the equation. So square root of 3x minus 2, that's the first function, equals to the second one, which is half x plus 1. Now I have to solve it, and in order to do so, I will start by squaring both sides. So I got 3x minus 2 equals to x squared over 4 plus x plus 1. I'm not a big fan of fractions in the equation, so just multiply by 4 straight away. I'll get 12x minus 8 equals to x squared plus 4x plus 4. That's a simple quadratic, so let's move everything to one side and we'll get x squared minus 8x plus 12 equals to 0. And let's use the quadratic formula. We get x equals to 8 plus or minus square root of 64 math, minus 48 divided by 2. And that gives us 8 plus or minus 4 divided by 2. If I take plus in the formula, that gives me 6. If I take the minus, that gives me 2. So these are the x coordinates. And all we have to do now is to calculate the y coordinates. Substitute 6 into any of the functions. I will substitute it into half x plus 1. So I will get 6 over 2 plus 1, which is 4. And I will substitute 2 into the same equation. I will get 1 plus 1 equals to 2. Now we have x and y coordinates of the both points. And that's going to be the answer. So point A is going to be 2, 2. And then point B is 6, 4. Okay, we're ready for the next question, which is probably going to be find the shaded area. Okay, indeed. So to find the area enclosed between the curves, we'll have to find the integral between the point of intersection of the top curve minus the bottom. Dx, of course. Okay, let's use the formula above. So we have to find the integral from 2 to 6. These are the x coordinate of intersection of 3x minus 2, 2 power of 1 over 2, minus x over 2 plus 1 dx. Okay, so first off, I just want to expand the brackets. The integral from 2 to 6, 3x minus 2 to the power of a half minus x over 2 minus 1 dx. Okay, and now I can integrate. I will get 3x minus 2, start with the bracket. Increase the power by 1, gives us 3 over 2. And then divide by the new power. So divide by 3 over 2, get 3 at the bottom, 2 on top. And don't forget, because you have 3 next to x, that goes at the bottom as well. Very important not to forget about this. Minus the integral of x over 2 is going to be x squared over 2. Then we had 2 at the bottom. So all in all, we got x squared over 4 minus the integral of 1 is just x. And we will have to substitute the lower limit and the upper limit, which is 2 and 6. Okay, so let's do the substitution. We'll get 2 times, that's 16 to the power 3 over 2 over 9 minus 36, which is 6 squared, over 4 minus 6 minus, I prefer to keep it in bracket. And let's substitute 2 into the expression that we've got. So it's 4 to the power 3 over 2 divided by 9 minus 1 minus 2. Okay, so it gives us 2 times 64. 64 math again, over 9 minus 9 minus 6 in a bracket. Oh, don't forget the minus. We've got 2 times 8 over 9 minus 3. Okay, and that simplifies to 4 over 9, which is going to be the final answer. Over 9. Let's move on to the next question. Okay, the next one is about graph transformations. And to start with, I'm going to combine half x minus 30 as one fraction. So I'll get 4 times sine x minus 60 over 2. And now I can start describing transformations. And it's very important to keep them in order. So the first one is going to be, well, x minus 16. That's the way you would calculate it if you were giving a certain value of x. So it's going to be the first one. Then I will think what's going to happen when I divide the result by 2. That's the second. And finally, I would have to multiply by 4. So that's going to be the third part of our transformation. I'm actually ready to state the answer straight away. So first, when I subtract something from x, it's going to be translation. So the first translation. The curve is going to move to the right 60. So the vector is going to be 60, 0. Next one, when I divide something with x by 2, there's going to be a stretch. And then the stretch factor is 2. And the third one, when you multiply the output by 4, all the output values are going to be 4 times bigger. So it means we're going to have a stretch again. By the way, I need to specify what happens in the second step. It's not stretch in y-axis, it's stretch along x-axis. So let's say parallel to x-axis. Then for the third step, we're going to have a stretch parallel to y-axis because all y values are multiplied by 4. So it's going to be a stretch. Stretch factor equals to 4, and it's parallel to y-axis. I think that's not bad for 5 marks. Let's move on to the next one. Okay, we've got the equation with trigonometry, and to start with, I'll divide both sides by 4, and I'll get sine x over 2 minus 13 equals 2, square root of 2 over 2. Then I will take the inverse sine of both sides, so I'll get x over 2 minus 13. Inverse sine of root 2 over 2 is going to be, okay, pi over 4, but we're actually in degrees, so that's going to be 45. And now, very important, whenever you take the inverse function, you should automatically think about the second value. So for the sine, it's going to be 180 minus the first one. So 180 minus 45. By the way, for the cosine, that will be 360 minus the first one. But in our case, that's going to be 135 And I can solve both equations for x. Let's start with the first one. It gives me x over 2 equals to 75. Multiply both sides by 2, so I get x equals to 150. Or, let's have a look at this second equation. X over 2 equals to 165. Multiply by 2, so x equals to 330. Okay, let's state both values as the final answer. Answer 150 degrees or 330 degrees. Time for the next question. Okay, the next one is about the circle, the center and the radius, and we'll have to remember the equation of the circle, which is x minus a squared plus y minus b squared equals to r squared. And that brings us to completing the square. I'm going to rewrite the equation, so I get x squared and x together, x squared plus 6x, and then I got y squared minus 2y together, and then minus 26 equals to 0. Now I'm going to complete the square in these two brackets, so x plus, remember how to complete the square, it's going to be half of a number, which used to be next to x squared, minus, always square. Whenever we got, so minus 9, plus y minus half of the number, which is 1, squared minus square, 1. And don't forget, we used to have minus 26, so just copy it here. Minus 26 equals to 0. Now let's simplify that. We get x plus 3 squared plus y minus 1 squared minus 9 minus 1 minus 26. All in all, we got minus 36 equals to 0. And the equation is x plus 3 squared plus y minus 1 squared equals to 36. Now let's compare this to the equation of the circle. So the center of the circle is A and B. Center is x minus 3, y equals to 1, and the radius is going to be 6. Now let's have a look at what our question is. Find the coordinates of the lowest point on the circle. Okay, let's draw the circle. Now this point is minus 3, 1, and the radius is 6. And that's the lowest point of the circle. Y coordinate is going to be 6 lower than the y coordinate of the center, which is 1 minus 6, so it's minus 5. And the x coordinate is going to be stay the same, so it's minus 3. Here's the answer. The lowest coordinate is minus 3 minus 5. Next question. The next question is about intersection one more time. And let's state both equations again. So y equals to kx minus 5, that's the line. And the equation of the circle is x squared plus y squared plus 6x minus 2y minus 26 equals to 0. So to find the points of intersection, we would have to solve those equations simultaneously. And they're asking for the value of k, for which we have two distinct points. So that means simultaneous equations must have two solutions. Okay, to start with, let's substitute y equals to kx minus 5 into the equation of the circle, and we'll get x squared plus kx minus 5, kx minus 5 squared plus 6x minus 2, put y in brackets, kx minus 5 minus 26 equals to 0. Let's expand the brackets. get x squared plus k squared x squared minus 10 kx plus 25 plus 6x minus 2kx plus 10 minus 26 equals to 0. So that's a quadratic equation. And let's combine x squared with x squared, x with x, and numbers with numbers. So we will get 1 plus k squared times x squared. Yeah, I just factorized it. Then for x, I will get plus 6 minus 12k times x. Then if I simplify all the numbers, I will just get 9, then equals to 0. So that's a quadratic equation. And because we are looking for the values of k for which you have two distinct points, that means this equation must have two solutions. Must have two solutions. So for the quadratic equation to have two solutions, we must get b squared minus 4ac bigger than 0. So b is the coefficient of x, so it's 6 minus 12k, a equals to 1 plus k squared, and c equals to 9. Let's substitute this into b squared minus 4ac, and we will get 6 minus 12k squared minus 4 times 9, that's 36, times 1 plus k squared. And that must be bigger than 0. Okay, let's expand the brackets and solve it. We'll get 36 minus 144k plus 144k squared minus 36 minus 36k squared bigger than 0. We're going to simplify that, collect the like terms, and we'll get 108k squared minus 144k bigger than 0. Now, how to solve quadratic equations? I do recommend drawing the sketch, just a very quick one, only with relation to x-axis. So our quadratics is going to open up because the coefficient of the square term is bigger than 0, so it opens up. And we're looking for the values for which the quadratics is bigger than 0, so it must be above x-axis. So here it is below, to the right plus, to the left also plus. And now we're looking for these two values. And that happens when the quadratic equals to 0. So I'll have to make 108k squared minus 144k equals to 0. And then I'll have to solve it. I will factorize. And split it into two equations. That gives me k equals to 0, or the bracket equals to 0. And from that equation, I will get k equals to 144 over 108, which is 4 over 3. Okay, let's go back to our sketch. Now we know that this value is 0, and the one on the right is 4 over 3. Now we're looking for the values for which the quadratics is bigger than 0. So that means everything to the left of 0 will make quadratic bigger than 0, and everything to the right of 4 over 3 will also make quadratic positive. So that means k should be less than 0, or k should be bigger than 4 over 3. That will be my final answer. Next question. Right, so first of all, I will have to find the nature of the stationary point, and I'm already given the second derivative. So the nature of the stationary point depends on the sign of the second derivative. If the second derivative is bigger than 0, then the stationary point would be minimum. If the second derivative is smaller than 0, then the stationary point would be maximum. So let's evaluate the second derivative when x equals to minus 1. X equals to minus 1. Just substitute it into the formula, and we will get 6 minus... minus 1 cubed is plus, so 6 plus 4, which is 10. 10 is bigger than 0, check on that. So that means the point is minimum. Minimum. Right, part B. We have to find the equation of the curve. So basically we're looking for the equation of the function given the second derivative. Now, if we integrate our derivative, we get the original function. If we integrate the second derivative, we get the derivative. So that means we'll have to integrate the second derivative twice. Let's do that. To start with, I will copy the equation of the second derivative, which is 6x squared minus 4x, and I will use indices, so to the power of minus 3. Okay, to get the first derivative from the second derivative, I'm going to integrate it. dx, okay, so 6x increase the power of x by 1, 3 divided by the new power, minus 4x increase the power by 1, minus 2, divided by the new power, which is minus 2. Let's simplify that, and I'm not going to forget about c. 2 over x squared plus c. Okay, at this point, we can figure out the value of c. How? We know that the curve has a stationary point at minus 1 and then 9 over 2. And then if I have a stationary point, that means derivative equals to 0 at the point minus 1, 9 over 2. So that means I can substitute minus 1 into the derivative, and I must get 0. Okay, let's do that. So substitute minus 1, I'll get minus 2, plus 2, plus c, and that should be 0. So from here, c equals to 0. Okay. Let's copy our first derivative. It's 2x cubed plus 2x to the power of minus 2, and we know c is 0, so no need to write it. Okay, to find the function from the derivative, we'll have to integrate it one more time. So y equals to the integral of 2x cubed plus 2x to the power of minus 2 dx. Increase the power by 1, divide by the new power, plus 2 times x to the power of minus 1, divide by the new power. And again, don't forget to write plus c. Okay, let me rewrite it as y of x equals to x to the power of 4 over 2 minus 2 over x plus c. And how do we find the value of c? We'll have to substitute the point, minus 1 and 9 over 2, into the equation. So we'll get 9 over 2 equals to 1 over 2 plus 2 plus c. And from here we can find c, which is equal to 2. Okay, now we're ready to state the final answer, which is going to be y equals x to the power 4 over 2 minus 2 over x plus 2. And let's move on to the next question. We need to show that there are no other stationary points on the curve. And to start with, how do we get stationary points in the first place? We get them when the derivative equals to 0. So we would have to explore the equation for the derivative one more time. Let's find that equation. It is here, and c equals to 0. So let's copy the equation and make it equals to 0. So we get 2x to the power 3 plus 2 over x to the power of 2 equals to 0. Then if we're looking for the stationary points, we'll have to solve it. I'm going to multiply both sides by x squared, which shouldn't be equal to 0. So we get 2x to the power of 5 plus 2 equals to 0. Divide both sides by 2. X to the power of 5 plus 1 equals to 0. X to the power of 5 equals to minus 1. Take the fifth root, and we get x equals to minus 1, which is already the stationary point that we're given. The question is minus 1, 9 over 2. Therefore, there are no other points. And I'm just going to write it down. Therefore, no other points, stationary points. Okay, now I think it's the time for the last question. Right, so the last question is about differential equations. And we're given that the point A is moving along a curve, so that y-coordinates of A is increasing at a rate of 5 units per second. So the rate of increase of the y-coordinate is going to be derivative of y with respect to t. So dy over dt equals to 5. Now, what are we looking for? We're looking for the rate of increase of the x-coordinate, that is dx over dt. And we also have the function y of x equals to x to the power 4 over 2 minus 2 over x plus 2. Okay, let's try to think, how can we get dx over dt from what we are already given? Let's start with dy over dt. How do we get dx over dt? Now, we don't really need dy. So it means I will multiply by something over dy. What should be on top? We need to get dx. So I'll put dx on top. And I already know that dy over dt equals to 5. Now, I need to find dx over dy. How can I do so? I can do it by differentiating y. I will find dy over dx that equals to 4x cubed over 2 plus 2 over x squared. Then derivative of 2 is 0. Now, we're given that x equals to 1. So from here I can substitute x equals to 1 into the derivative, and I get dy over dx equals to, okay, let's substitute it. So I get 4 over 2 plus 2 over 1, so I get 4. That means dx over dy equals 2. Let's flip it over, so I get 1 over 4 instead of 4. Okay, now let's combine it together. I know that dx over dy is 1 over 4. Multiply it together, and we'll get 5 over 4, which is going to be the final answer for this question. Okay, that's it for this exam paper. I hope that you find it useful. Bye.